All right. Well, welcome back, everyone. We are back from the break here. Thank you very much, Veronica, for a fantastic talk. It was very informative. And with us today, we have Praveen now. Praveen, how are you doing?
I'm doing great, Alexander. How are you?
Good, good. And it's late where you are, right?
Yeah, it's around like 2:30 a.m.
Wow. And where
But
about?
uh, but this ML.NET conference keeps me working for this.
Yeah, and whereabouts are you located?
I'm located at Bangalore, India.
All right, awesome. And you're a cloud architect and an avid community speaker, I hear.
Yeah. So just to brief you on who am I, so I'm working as a cloud architect at Harman International. It's a Samsung company. They are into audio video, and you might have heard about JBL speakers. So that's one of our brand. And we are developing a platform for audio, video, and lighting control, which is to control all these devices remotely through a web app. Then we are leveraging Azure over there, and I have around like 15 years of experience. After that, most of the experience is into Microsoft technologies, right from MFC, VC++, then WinForms, WPF, then web APIs, and now into cloud.
Cool. So how did you first come in contact with ML.net?
Yeah, so there was a story about that. So I used to attend few meetups for the past couple of years, and I was attending few meetups related to the machine learning field. And in one of the meetups, I got a few use cases that got me excited about this field. And as a like a C# developer, I kept on looking for the options that is available in .NET for machine learning, but I didn't find much of that one. But last year I got to know about this ML.NET. Plus, before that, I got to know about TensorFlow.net. So there are few kit packages that are written in .NET. So that got me excited, and I got motivated to work in this field. And therein, like from the release point 4, I started to look into the things happening around ML.NET.
Awesome. And today you're going to talk about DataFrame API, right?
Correct, correct.
Awesome. Well, we're very excited to have you here. Thank you very much for staying up so late to give this talk and sharing your experience and expertise with the audience here that are watching in. And we will be asking you questions after your talk. So anyone who has questions to Praveen here, put them in either Twitch or YouTube or Slack, and we'll make sure to ask them. But for now, Praveen, the floor is yours. Take it away.
Okay, thank you very much, Alexander and John. So, welcome everyone to the virtual ML.NET Community Conference. This is the first edition. I am really excited to speak on this a great topic of ML.NET. So, being a .NET developer, it's really inspiring to see the things happening around in the machine learning, and that too from a .NET perspective. So today I'm going to talk something related to the data frame that was recently released, I think few months back, the first version of it. And I think Daniel has given a good overview about the Jupyter notebook, and he does a little bit on the data frame as well. And I'll try to take it forward and try to be aligned only to the data frame and ML.NET a little bit. And the area of the domain that I'm going to cover is the COVID-19, because that is a current area and happening area, and which everyone knows about it, the pandemic that is going on. And because of that, everyone is like have to stay at home. So with that, I'll just start my presentation. So this is a brief introduction that I just gave. Like, I'm a cloud architect at Harman, and the domain is audio video control. So my area of expertise is cloud and distributed computing. Interest area is AI, ML, cloud, and IoT, and I'm based out of Bangalore, India. So before I start, I would like to give some acknowledgements. So first one is the dataset. I would like to acknowledge John Hopkins University's for providing the data set for this COVID-19 things happening, like how many confirmed cases are there, how many deaths are happening, how many actual cases. So these all things have been provided by them. I'd like to acknowledge them. Then for Python visualization, I tried to go through one of the notebook which was written by XSB, but it's written in Python. So I tried. This was my source of inspiration to convert it into ML.NET. And not these like the great people that we have, Alexander and John. So this is the first time I'm looking at John. I've been following his video tutorials where I just got to hear his voice, but as part of this conference I got to see him like face to face. So I'm glad that these two guys have been doing a great job in organizing this thing, and behind the scenes there is a lot of work that is happening, and they have done it like flawlessly. I really want to thank them. Last but not the least, the sponsors for the event like Excella and the Wintellect. So COVID-19, so what is it? As per Wiki, this is coronavirus 2019, disease 2019. That is a short form acronym for COVID-19. It's an infectious disease caused by severe acute respiratory syndrome, coronavirus 2. So they call it SARS-CoV-2. The disease was first identified in 2019 in Wuhan, the capital of China's Hubei province, and has since spread globally, resulting in the ongoing 2019-20 coronavirus pandemic. So, I think almost most of the countries have been affected with this, and there is a havoc that has created, and still we don't have the vaccine for this one. But like if we follow some precautionary measures, then we can refrain from this disease. So it's like a really a pandemic which is causing a havoc throughout the globe. So there are some statistics that have put up here. So if you look at these statics, like this is the confirmed cases as of 28 May 2020. So these are like 5 million confirmed cases, and there are deaths around like 0.35 millions. But if you look at this data set, you can't say how it's very static data set. You can't predict what has happened in the past, what is going to happen in the future. But because these are just numbers, so this is what a statistics mean. But if you look at this graph, you can predict what has happened in the past and what may happen in the future as well. So if you combine this data, the left one, you can't make any judgment out of that one. But if you look at the plot, you can actually make some judgments out of that one. So that is where we do exploratory data analysis. So this is another two graphs. So like it talks about the total confirmed cases as per the different countries, and on the right side we had total confirmed cases on a per day basis, how they are increasing. So this topic is more about the exploratory data analysis. So what is it? First of all, as per Wiki, in statistics, EDA is an approach to analyzing data sets to summarize their main characteristics, often visual methods. So when we get a data, we generally not able to interpret what is residing in that one, what information is hidden in that one. But as we apply some exploratory data analysis on that data, we start getting some inferences out of that one. We generally plot some graphs, we generally plot some tables out of that one. We manipulate the data, we aggregate data at some places to get a better understanding. So it's a statistical model that can be used. A statistical model can be used or not, but primarily EDA is for seeing what the data can tell us beyond the formal modeling or hypothesis testing task. So I just wanted to give an analogy here of a house. So if you want to buy a house, what all things will come into your mind before buying a house? So you may look for number of bedrooms, you may look for type, whether it's an apartment, it's a villa, whether how is the locality, and how is the crime rate in that locality. So these are the factors that may help you in making your decisions. So if you get a good overview about these items, then you can make a better judgment for buying a house. So what is the time series analysis? So time series analysis, that is the analysis of data organized across units of time. So you plot a graph of one item against the time, and you get the time series. So as you can see on the right side, we are plotting a number of total deaths over a period of time. So it starts from January 22 and goes till January May 27. And if you look at here, somewhere around like March 21, there is a sharp increase of number of deaths, and it has been increasing exponentially. So this plot gives us a very overview, okay, how things have moved in the past and how it may happen in the future also. So the plots are very helpful in that one, and it helps understand past trends and plan for future. This is what I already discussed. So there are different type of trend time series analysis that we can perform. So like first one is trend. So trend is like the normal trend, how's the, for example, if you take a case of a e-shopping cart, e-shopping application, so how's the sales going on for that one? It may be like a regular, so there is a trend of going up at some time, then there is a trend of going down at some time. Then seasonality is about like during Christmas, during Thanksgiving, the sales may go up, or during dormant period it may go down. So those comes under seasonality. And third one is irregularity. So irregularity, the best use case would be like the current situation that we are facing of a pandemic, wherein the sales have really dropped for some of the online retailers or some of the retailers, and it was not expected anywhere, but it has come. So this will tend to be part of the irregularity time series analysis. Then there is a cyclic, that means after a certain period of time there will be a uprise, then after a certain period of time there will be a downfall. So it may be considered to be like a sinusoidal waves, where it may go up at a certain interval, then come down, and then go up. So it remains constant with those cycles. That means it will go up for some time, then come back to some time. So these are the four types of time series analysis we can perform. And so today we are going to perform one of the time series analysis on total number of confirmed cases uh, during this pandemic of COVID-19. So before going jumping into that one, I like to spend some time over data frame. So Daniel already touched upon this one, and I like to extend on that one. So data frame, if you look, it's something that is coming from the Python, wherein it's present in Python, it's present in R as well. Most of the data science languages. So it's mainly prevalent there because it allows you to perform analysis on a huge data set, and you can perform multiple operations on that one, like addition, subtraction, then insertion, deletion, then you can group by, you can sort. So a lot of things you can do there. But here in, it's mainly derived from the Python and R. So this is how to explain what is a data frame is. If you look at this table, it's nothing but a normal Excel sheet with some rows and columns being represented. So what data frame does is it tries to fill in this thing into a data frame object and display it. So when we convert this one into a data frame, It looks like the one that is present on the right side. And as you can see, it has added one more column with the values as 0, 1, 2, 3. So those are nothing but the indexes of the rows which are present. And generally it starts with 0, not 1. But these are it's configurable, so you can change the index as well. You can assign any of the columns as an index. You can give a name to the indexes. So it's really configurable in Python. Okay, so coming to the .NET data frame. So what is it? So it's a collection of columns. It is very similar to Python data frame. So what Microsoft has done is that they tried to bring their feature of data frame to .NET so that people who are wanted to work on the data science field, they can easily work with this data set with this data type. And basically it's a collection of columns, and in this the whole data is present in the memory, so everything gets loaded into the memories. That's why it's called a in-memory representation of structured data, and it's very similar to Python data frame. Then you have there are some features that I have listed here. So first one is you can load a data set from a CSV. You can do a row or a column selection. You can join or merge data frames. You can group by, and you can fill the null values. You can handle the null values as well. So very similar to what we have in Python, and but not to that powerful as in Python. The reason being it's recently introduced, so it will take time to get to that level of Python data frame. So there is a question that comes very often, we already have a data view in ML.NET. So why do we need a data frame as a different data type? So I tried to list down some of the differences and some of the similarities between them. So first one is so data frame is part of the Microsoft.data namespace, whereas iDataView is part of Microsoft.ml. So there is no correlation. These are two very independent things working individually. So there is no dependency of a data frame on data view. Sorry, on there is no dependency of iDataView on data frame. So if you want to see how they are related, is like there is an analogy like a data frame can be considered as a list where you can do multiple operations on it, such as addition, deletion, insertion, getting by index, all those things. Whereas iDataView is kind of an enumerable or read-only thing, which is immutable, whereas data frame is mutable. So data frame is meant for .NET developers interested in data science, that is for exploration, whereas iDataView is more inclined towards .NET developers who are interested in machine learning, that is for making some predictions or forecasting or such kind of things. Data frame is schemaless, whereas iDataView is schema bound. So schemaless, I mean to say you need not to define any class for the data. You need not to have a knowledge about what is the what all columns are present in your data, and you need not to create a class or a class with properties for those data types. So it will be automatically handled by the data frame, and it will load and give you a tabular data. Whereas in data view, you have to define a class that mimics your data that is present in the CSV or another source, and there you need to define it as a features, plus you need to define a label over there. So the data type for the features is also very important there. So it requires a prior knowledge of the columns or the data type of those columns that are present in the CSV. Data frame is eagerly loaded. That means everything is as soon as you load it, you can work with that one. Whereas DataView is lazy loaded, so till the time you perform any operation on DataView, it won't be loaded. So, for example, till the time you call predict pipeline.fit, nothing gets loaded in DataView. Only at that point of time it gets loaded. Then data frame is in-memory representation of the data. Then data view is a stream based with a forward only cursor. That means you read the data as per your records. You can read one record. It reads records row by row, and you continue to read those things. Data frame has a random access similar to your list, whereas DataView doesn't have a random access as it's a forward only read cursor. Data frame is easy to debug because it's eagerly loaded, so you can debug the things quite well. Whereas data view is hard to debug because till the time it's called by someone, then only you will be able to see the values. So, for example, if you are calling pipeline.fit, then in that case, only that point of time you will be able to see the values that is present in that, or you have to call it inside a for each loop or something like that, but then you will lose the performance improvement that is present in the data view for lazy loading. Data frame supports only CSV as of now, and that is the only data type they have provided as of now for data frame. Whereas data view supports CSV, enumerable, and relational DB. So it's very much required for your machine learning things. Whereas for exploration, many times it's mainly present in the CSV, but I think Microsoft is going to add support for other types as well in data frame. Now the last point is very interesting here. It's like a data frame is based on Apache arrow formats, and what Apache arrow format means, it maintains a kind of a standard. It's a kind of a standard which all the consumer has to be follow. For example, you have Spark, Apache Spark, you have Cassandra, or any source of data set. It has to follow that one, and it's very efficient in terms of the memory representation of the data, and it's based on the columnar data. Whereas data view is schema based, so you need to know what all the columns are present there, what all the data types of that column should be there. So it's very much coupled to the schema. Now coming to the ML.NET, so we just had a look at the data frame for exploration part. Now this ML.NET is I have used mainly for predictions here. I did a small prediction on the COVID-19 data set, and it was a time series prediction wherein I've leveraged like loading a data into an ML context, creating ML pipeline. Then in the last I'll be predicting confirmed cases in next 7 days. So I have a data of around 107 days that I've trained my model on, but the data itself is very less. So, but I have trained it on that one, and I try to predict what will be the values of next 7 days if we continue to have those kind number of confirmed cases. So for that, I have used single spectrum analysis. So single spectrum analysis is nothing. It's a powerful framework for decomposing time series into trend, seasonality, and noise component, as well as forecasting future values of time series. So I just mentioned in previous slides about the different type of time series evaluation that we can perform, or an analysis that we can perform. So single spectrum analysis allows you to perform those kind of things, and it performs the way it works is a single spectrum analysis perform spectral analysis on the input time series, where each component in the spectrum correspond to a trend, seasonal, or noise component in the time series. So the use case, maybe you can say it's like a anomaly detection or forecasting. So we leverage the forecasting part of it for predicting the number of confirmed cases in next 7 days. And the API that is used here is from the time series catalog, that is forecast by SSA. And for visualization, I have used the Plotly. That is a graphical user interface that is being provided. And I have created a bar chart, a scatter chart, and a pie chart. So these are the things that I have used. And this is just a preview about on the things that is being generated out of that data set. So on the left, you have a pie chart representation of number of confirmed cases and a number of deaths and number of recovered cases. Whereas on the right side, you can see it gives a bar chart for different countries with the number of confirmed cases. So, and for prediction, this is before the model has been trained. This is from the analysis part. So this is a plot of number of confirmed cases right from 22nd of January till 5th of May. And based on this data set, we try to predict the next 7 values, and these are the values that I got out of my ML model. And I try to plot that one, and it comes like this. And there is a slight decline in the predicted value. The reason being the data set is very less, so model is not able to interpret it very well or come up with a very good algorithm for that. But as you can see, still the number is going up in line with the previous records. So it's also increasing similar to what we have previous increase. So not a very good prediction, but the model is predicting in a little bit a better way, because the things are going in an upward direction only as per the last trend. So with that, I'll just move on to the demo side. And if you need anything, okay. Okay. So okay, so this is my Jupyter notebook, and it's being divided into part one and part two. Part one is about making the exploratory data analysis, whereas part two is being extended for the prediction. Okay, so this is a notebook that is created. So like acknowledgement for Job Hopkins. Then this is the place where you can get the data set about this. Then I have explained a little bit about data frame, then what all things I'm going to perform. And it's a two parts thing. I've divided into two parts this section. Then this is how we just load our packages. So currently I'm using Microsoft.ml, data.analysis, and Plotly. And this one I'm going to tell you how I am using CSV helper here in a minute. So these are the namespaces, constants. So this is about the utility function. So it is, I think, quite well explained by Daniel in the previous presentation. So I'll just skip on that one. It is about representing your data in a very formatted way. Now, coming to this is one another helper function. What it does, it replaces a character in a cell of CSV with a defined separator. So I'll explain you why it is required. So for loading a data set, so Loading this CSV file. So these are the so this directory contains date-wise data about the COVID-19 cases. So I'm using that only. This is how I'm downloading it from the GitHub. Now this is the thing I was talking about. I need a helper method for my data set. So there is a issue in the load CSV method of a data frame. What happens is like this data set contains comma or the separator within the cell values. So this is my column which combined key which has some separator, and we are mentioning that when we load our data set we are giving the separator value as comma. So the current implementation of load CSV in data frame, that it fails with that, it fails for that one. So what I have done is I'm loading I have created a helper function that goes and changes these separators with some other character, for example underscore. So after this the all these will be replaced with the underscore and we can load this data set. So this is just about a workaround for the transformation of that one, and there is already a issue logged for that one, and I think the Microsoft team is working on that. Now this is about that one, this is the one where I'm calling that where I'm passing the original file name, new file name. Yeah, this is the main thing. So here we are passing the loading the CSV and creating our data frame. Now coming to the data analysis part. So first we wanted to see what is the range of the records in the data set. So from a data frame you can use the columns property, and you can provide the it's a collection wherein you can provide the last updated value, and it will give you the value counts, will give you all the values within that column. And I tried to sort that one, then I got the start date and date, and it is both same. The reason being it is both same because this is a data set for 1 day, so that's why there is no range present here. Now if I wanted to visualize the data here itself, I can just either call display methods as an inbuilt function from the .NET for displaying the data frame. So what it does, it displays the 10 records, and this is what I was talking about, the index thing, and it will list down all the columns that is present in the data set with their values. Now there is another function called as head. It allows you to get the top 5 records from your data frame. Similarly, if you want to see the random records, like the sample is used for displaying the random 6 records. So it may be in any order or anything within that data set. Now, if you want to see, if you want to preview what is present in your data set as a like a statistics about your data set, then you can just call that description. So description has like a length, that means how many records are present for one type, and what is the maximum value, what is the minimum value, what is the mean value for that. So this is about that. And then information, like if you want to see what is the data type of each column that is present, and what are the values it contains, then the total and number of values. So we can see like this is like string, and so then you have single, then you have string. So it's a combination. So each data frame like in Python data frame, the constraint is the column will hold data of one type only. It can't have a mix of data types. So that is why you get the type out of that one. Now we will move on to the data cleaning part, and with the data cleaning part, what we can do is we can remove the outliers, we can remove the null values, we can merge two values into one. We can remove the unnecessary things that becomes a noise for the analysis, and that way the data will be more readable, or maybe you can say the data will be more accurate to for our analysis. So I'll just give you an example here. What is the invalid data here present? So if you look at the active cases, so it's a negative value. So this is how I got to know that there is something wrong within my active cases. Okay, so I just did a description and got a minimum value as minus of for the active cases. The way we calculate the active cases is we take the confirmed cases, we subtract the deaths and the recovered cases. So if you look at the confirmed cases and deaths and recovered, so it cannot be less than zero. So it cannot be negative. So this tells us, okay, there is a problem with our data set and we need to remove these irregular values from this. So for that, we need to filter out these values. The way we filter out is we use element wise less than API from the data frame columns. So we can say, okay, the values which are less than zero, get me those values. So this will give me a column, invalid active filter, and what I will do, the data frame exposes a filter API that takes a column. So these are the different primitive data types that is present in the data frame. So mainly the data frame has a class for string data frame column, integer, boolean. So like that, it has covered mainly most of the primitive data types, and you can create your own data type as well, columns as well here. So when you filter it out, then you can see when we print this one, we can see that there are some cases which have the negative values. For example, these all values are negative for the active cases. Now we got to know the list of records that is having a negative active cases. So if you take any record and apply a formula to calculate, like minus 13 index at 5. So if I take this one as an example, so I have 10 minus 51, then minus 0, so it comes as minus 41. So that means it's based on this thing only, and it's invalid use case, invalid record. So what we will do is we will we want to remove these invalid cases. For that, we again create a column with a condition such as element wise greater than or equal to 0. So we are only interested in values whose active value is greater than 0, and we do that one using a primitive data frame column and applying a filter with for that column. Now once we do the description, we can see that there are no values with negative, there are no active cases with negative values, so we have a 0 here. That's the minimum value that we got. So that's how we did the data cleaning part of it, or from a data frame. So we can see that the negative cases have been removed from this. And the good part of data frame data type is, like, nowhere we have mentioned about the schema of our data set. So it's like a schema less. Now coming to the visualization, so I tried to visualize few things just to keep the things very simple, and didn't go a deep into visualization here, but if required we can explore more on the plotly charts that is available, and explore more, plot more of these charts. So first one is how do we collect the data? So for from the data set, we know that there are some confirmed cases, there are deaths, there are recovered cases. So we just got all of these. Then we got a sum of this one. So data frame supports aggregating the values. So we got the total values out of that one. Then we try to plot all these three using a pie chart. from a plotly. So this is how it comes, and you can move over this and you can get the see the values and the percentage. Now we wanted to see the countries, top 5 countries with confirmed cases. So the data for top 5 countries is not present in CSV file together. So we need to do a group by, and so in this cell I have used group by, sum and order by descending features of a data frame, which is very helpful for grouping the records and getting a sum out of that one, and later on sorting it. So like I'm getting a country confirmed group, then top countries column cases, then I have to, so this code is for representation only, it's not a very optimized. I try to keep it very simple just to make it better for understanding, and I try to plot it as a bar chart over here. Now we can see the number of cases against each country, top 5 countries, like US, Brazil, Russia, United Kingdom, and Italy. So this that is for confirmed cases. Similarly, I did a plot for deaths for top 5 countries. So this is about that one, and same is the case for recovered cases. So we can say the recovery is quite good in Germany, in Italy, then Russia. So with this, we can say that things are going good in terms of the recovery, but with deaths and active cases, still the numbers are quite high. This is about one chart of related to the India, and you can see we have 1.58 million confirmed cases, then recovered, and deaths are like 4,500. So this whole thing gives a little bit overview about the COVID-19 pandemic that has happened, how many deaths have occurred. Because if you just look at the numbers, you won't be able to realize what has happened, and how things are there in that one. So we need to visualize it better. So the data frame helps us measuring those things and give a better visualization. Now I'll just move on to the part 2 of it, wherein I did a small prediction for this data set. Okay, so it's the same similar thing I have just explained what is that. So the main intention is to look at the time series analysis for the number of confirmed cases for 107 days, 127 days, and based on that predict the outcome for next 7 days. So this is how I am so here you can see the time series package I have included. It gets installed. That is the extra thing that I got here. And this is something similar to what we see. Then this is a formatter for the table. Then for time series there is another data set that is present, a different one compared to this. So if you go on this GitHub link, you see time series, and here I have just taken the confirmed global cases. So I'm doing the analysis only on the confirmed and that too on a global cases. Okay. So there is a catch here, like the data that is present is like this. You have columns and the dates also along with that one. So like loading it into DataView, it's difficult because the number of columns are quite large, plus making a prediction out of these like for time series we just need one the date range plus we need the one attribute of it. For example, we need a number of total confirmed cases, so that we can get if we just add up all these values, we will get up those values. So there is no transpose or anything present, transformation present in data view that we can do for this. So what I did is I just changed this one into a different format and got it in this format, wherein we have a list of dates plus we will have the total confirmed cases against those dates. So this is how I have structured this the data set that is present there, and the way it is being structured I have just explained it here. So if someone wants, they can just refer to this one and they are good to go with this. So now we have the data about the dates and number of confirmed cases, and so this like the prediction is mainly done using ML.NET. So now we have left the area of data frame and we are exploration area. We have come into the data view part. So for the data view we need to have a schema or a class that maps to our columns that is present in the data set. So I just created a data set for that one, class for that one, like a date which is of type date time and total confirmed is of type float. So it maps to our both the attributes present in our data set. Now this is for our forecasting, like this is an array which will hold the values for 7 days of number of confirmed cases. Now before doing the prediction we just wanted to visualize, so we can visualize it through our, again you can use the data frame or you can use the data view. For the simplicity I have just used the data frame here. It is just only for visualization purpose. So we can see like what are the top 10 values, what are the last 10 values, we can see the last date and what is the number of cases in that can tell us. And this is it can tell us, okay, if there is any negative values or anything like that, this will tell you the statistics about the data, how many mean values, how many max value, what is the mean value, what is the max value. Now number of confirmed cases over time, so we again get the values from the date column and total confirmed column, and we try to plot it the cases over time. So this is how it comes. Yeah, so as we saw earlier that this is very similar to that one. We can say that around 19 or 21st of March, there is a sharp rise in the number of confirmed cases. It keeps on increasing exponentially. So this gives a overview of how the cases are increasing or decreasing over a period of time. So this plots helps us analyzing that kind of a situation. So we can say that the duration is from 22nd of January through 27. Then there are 127 records. Then the case on first day is 555. Then case on last day is 1.69 million. And number of confirmed cases was low in the beginning. There are a first jump around 12 to 2020 and an exponential jump around 22 March. So cases have been increasing at an alarming rate in the past 2 months. So if we look at this one, the cases have been increasing at a very high rate. Now for making the prediction is a standard process that we have been looking for the past 2 days. So we first create a ML context and then we will load the file from, we will use the load from text file API, but here we need to define our schema or the class against the columns that is present in our data set. So this is the file name, then we need to set the header as true and separator character as comma. So this will load our data set. Now this is the main thing where we are specifying what algorithm we are going to use for this time series analysis. So for creating ML pipeline for a time series analysis, we used a spectrum analysis, and ML.NET provides a built-in API for the same. So we provide these things, and in this we have provided a value for the horizon. So horizon is nothing but for how long in the future you want to predict something. So for the in our case, I have provided the value for horizon as 7. That means,
Praveen, I think
yeah,
unfortunately we have to start wrapping up a little bit here for
yeah,
this
I'm
talk.
just about to finish.
Awesome. All
Yeah,
right, go
great.
for it.
Thank you. Yeah. So this is for the 7 days. So when you create time series engine with your confirmed data and the confirmed forecast, and you do a prediction out of that one. Okay, so this is the value that you got. So for the next 7 days, and I just try to plot this one again, and the plot looks very similar to what I have shown in the PPT, and it's similar to that one. Yeah. So this is all about I have with respect to the data frame, and I had touched a little bit on the prediction part using time series, and hope you enjoyed this one. And feel free to ask me any question you have either now or maybe on the chat. Thank you.
Thank you very much, Praveen. That was great. So definitely a deep dive into DataFrame API and a lot of good learnings there for sure. Does anyone have any questions on the chat real quickly here before we have to jump into prepping the next one? Daniel has a question here. What value did you choose for and how did you find seasonality window size for a trainer?
Let me check. Window size is I just used 5, I think. Yeah, 5. Series length is 10,
Okay.
train size is 100, because my data is around like 127 records. So it's a very less data to do this kind of analysis, but this is just for representation how it works.
Okay, awesome. And we have these on GitHub, right? So anyone can come and look at them?
Yeah, let me tell it. Everything is here.
Perfect.
You have this part 1 and part 2.
Okay, even the speakers, awesome. Well, if you want
Yeah,
to, you can definitely post that into the chat or into Slack afterwards, and people can go and have a
sure,
look at it.
sure.
Perfect. Well, thank you very much, Praveen, for joining us today and giving this talk. It was very great, and thank you for staying up so late.
Thank you, and it was a privilege to be part of this event. Thank you.
That was awesome. All right, so coming up next is our last speaker of the day. It's Will Velida, who's going to talk about serverless apps and